Hey team, bit of a pattern here. Start early one day, late the next, early the next. Just here to announce that there's no problem today and the lockdown's over. I've run out of maths and we're finished. Yeah, no, the video's 5 minutes long. I'm sorry. April Fools. Well, according to this meme, April Fool's Day's been cancelled. Fair point. Okay, so a short problem today. Another geometry problem. We're going to look at some level 2 trig as well that you're supposed to know in this course. These three formulas are on your formula sheet. If you have never seen them before, you need to hit some YouTube videos up real quick. Just have a look at how these work. These formulas are for non-right angle triangles, but they also work for right angle trig. In the sense that if the angle's pi over 2, cosine of pi over 2 is equal to 0, so you just get a squared plus b squared equals c squared. The way that these things work, the capital letters are angles, the lowercase letters are the sides opposite those angles. And apart from that, these formulas are just known to be true for non-right angle triangles. You could prove them if you'd like to. There's heaps of proofs out there as well. Let's get stuck into this first question. Okay, problem 6. My goodness, we've been going for 6 days. 28. Show that the area of this parallelogram is 6 units squared. A parallelogram has sides of length 2 and length 4 and an angle between the diagonals of 45 degrees. Alrighty, solution time. First up, the area of a parallelogram is base times height. If you say the base is 4, the height is not 2, so the area is not 8. We don't have the height. We could turn it around and say the base is 2, but the height is not 4. So we know that the area is a little bit less than 8. In this case, we know it's 6. So instead, if we knew that if we could find the area of the triangle, then we could find the area of the parallelogram. If we knew what these two lengths here were, which I've labelled x and y, we could use that first formula, the area formula, for a triangle, and find it out perfectly fine. Remember, sine 45 is just 1 over root 2. We do have the cosine rule, though. We can relate those three sides to that angle in that triangle using the cosine rule. There's also a cool little thing that length there is x as well. The reason for it being x, these diagonals split the parallelogram into half, and all of these 4 triangles are similar triangles, so those lengths are the same. But just a little quick proof of that. If we take a line and then a line that's parallel to it, then another two set of parallel lines, put the diagonals in, and then measure these line segments. The line segment L and M are both 3.84. I can move that, move this shape around, and those line segments there, the diagonal, they bisect each other. Alrighty, so we've got all of that information. If we just evaluate the 2 squared and evaluate the cosine 45 and do the same for the bottom one, we get 2 equations that have both got x squared plus y squared in them. We can eliminate x squared plus y squared by subtracting these equations or by making x squared plus y squared the subject, either or. We do that, we get this nice relationship here. That tells us what xy is, which is cool because if we knew what x times y was, we don't need to know them separately, but if we know xy, then we can find the area of that triangle by subbing it into the first formula we started with. That comes out to be 1.5, and times it by 4, you get 6 for the area of the parallelogram. Okay, your extension question for today is on a similar sort of vein. You've got a trapezium divided into 4 triangles. The areas, the little a and b are not angles, so the areas of the top and the bottom triangle, so if they're a and b, find the area of the trapezium in terms of a and b. Be careful because normally the trapezium formula has the top as a and the base as b, so just be careful of what your notation